Welcome to the 5th UAM Feasibility Study webinar. Today, we are concluding our journey of the Chicago 2023 UAM mock feasibility study. A comprehensive report will soon be released, so stay tuned and follow eVertisky advancements. In this 5th phase, we will present the proposed Vertiport architecture. I know you all have been waiting for us to unveil the preliminary Vertiport design for the location at 6200 State Street, Chicago. But first, as per tradition, we will start from the findings. I'm Sandra Formenton, CEO at Vertiport, and I'm thrilled to be joined by our chairman, Giuseppe Caruzzi, and our globally recognized Chief of Architecture and Design, Giancarlo Zema. Without further ado, let's kick off the 5th UAM Feasibility Study webinar. Our Chicago 2023 UAM mock feasibility study took a comprehensive approach to assess the potential for urban air mobility integration within the selected location, and questionnaires played a crucial role in gathering stakeholders' insights throughout the study. The UAM feasibility study aims to reflect stakeholder and community aspiration and needs, and our 5 months approach consisted of several phases. We see here we had the first phase, the vision, the second phase, the land use specification. Then we had the built environment phase, the airspace architecture phase, and today is the day of the architecture phase. So let's explore the findings. In the vision phase, we had identified key aspects, including the need for a specialized workforce, efficient air traffic systems, and a commitment to sustainability. And it is essential for the Vertiport to align with the community's values and seamlessly integrate into the existing infrastructure. So the scope in this phase also highlights the potential for economic growth and increased civic participation through the UAM implementation. And this UAM location will cater cargo, passenger commuting, and first responders transit. The valuable insights gained during the vision phase form the foundation for the next phase, the land use specification phase. And this phase further refined the project scope by specifying the land requirements and other considerations necessary to meet the goals and also the aspiration identified in the vision phase. So during the land use specification phase, our focus was on uncovering valuable insights that are essential for the feasibility and success of our UAM initiative. And we made significant discoveries that have a profound impact on the overall project. We found out that property owners and developers were attracted to the potential benefits that UAM can bring to their plan, and key planning factors such as speed and efficiency were considered in the design of UAM infrastructure. We also identified a market demand for UAM in logistics and also freight, particularly for transporting large and heavy goods. And moreover, also we found that stakeholders were willing to embrace UAM to revolutionize last mile distribution and provide convenient transportation options for passengers over long distances. The UAM-enabled location will prioritize user experience by incorporating elements such as clear signage, efficient navigation, and a visually appealing Vertiport design that combines Art Deco and modern styles. Of course, also that will include comfortable waiting areas featuring lounge chairs will be prioritized to enhance passenger satisfaction. So a well-connected Vertiport that incorporates inclusive designs elements, self-guided parking, and organizational structure based on flight destinations. We also consider the energy efficiency and rainwater reuse systems, along with a balance of amenities for an inclusive environment. Additionally, to ensure efficient and secure and sustainable operations, comprehensive security measures and dedicated airspace, dedicated also spaces for eVTOL operator training will be integrated into the design. In the fourth phase, we talked about the architecture airspace when it comes to the eVertiSky design architecture for urban air mobility airspace structures that represents an innovative and comprehensive approach to managing and regulating UAM operations within a city. So this approach encompasses the eVertiSky UAM software-defined airspace and the four-dimensional trajectory reference box city operating system. So the eVertiSky UAM software-defined airspace enables enhanced airspace management, traffic management, and safety and risk management and integration with city infrastructure. On the other hand, the four-dimensional trajectory reference box city operating system enables precise trajectory planning, incorporates noise and environmental considerations, and also facilitates regulatory compliance and provides valuable data for analysis and planning. So as I said earlier, today is the day. So we are going to talk about, again, the architecture of our vertiport for the selected location. So thank you. Now let me introduce you to Giuseppe Caruzzi, chairman at eVertiSky, the visionary who brought our team together and made eVertiSky happen. Welcome, Giuseppe.
Good morning, everyone. And thank you, Sandra, and thanks to all of you. At eVertiSky, our mission is to transform urban transportation by developing state-of-the-art technologies and sustainable infrastructure. We envision a future where elevated mobility solutions seamlessly integrate into urban environments. With our dedicated team of experts, we strive to set new heights in urban air mobility. Today, we are thrilled to share with you the eVertiSky UAM Vertiport strategy, a significant milestone in our mission to activate urban air mobility. This strategy is the result of extensive research, analysis, and collaboration aimed at maximizing the potential of UAM in our selected location. eVertiSky, we understand the crucial role vertiports play in the success of UAM. That's why our strategy goes beyond functional structures. We aim to design vertiports that seamlessly integrate into the urban fabric, focusing on establishing vertiports as multifunctional hubs that connect with existing transportation networks. By strategically locating vertiports in high-demand areas, we maximize accessibility and convenience for last-mile distribution and passengers, ensuring that UAM becomes an integral part of the city's urban ecosystem. Before we delve into the vertiport design and architecture, I'd like to take a moment to introduce you to our Chief of Architecture and Design, Giancarlo Zema. Giancarlo's expertise and innovative approach have earned him recognition from prestigious institutions such as the Chicago Atheneum Museum, where he received the Green Good Design Award in 2022 and in 2023. Additionally, his remarkable contributions have been acknowledged with the Build Architecture Awards in 2023 for his outstanding work in creating the most innovative architecture. On another exciting note, we are delighted to announce the launch of the Rita Levi Montalcini Foundation Research Center in collaboration with UAM designed by Giancarlo. This remarkable project will see the development of a state-of-the-art facility along with an innovative vertiport. The build-out is scheduled to start in 2024 and is expected to be completed by 2025. Giancarlo's visionary designs and expertise play a pivotal role in shaping our vertiport designs and ensuring their excellence so at this point, the word goes to you, Giancarlo.
Thank you, Giuseppe. Before we proceed, I would like to express my gratitude to our CEO, Sandra Formenton, and our CTO, Stephen Philpott, for their leadership in this study. During the architecture phase, we carefully considered the previous phases, as well as the space and the urban air mobility corridors requirements and constraints, ensuring that our design integrates seamlessly within the urban ecosystem. So let's get started. Well, for the preliminary design phase of the Vertiport, we took careful consideration to the unique attributes of the selected location. Situated between the Washington Park and the second major Chicago Transit Authority mass transit stations, the site offers advantageous features that shape the design and functionality of the Vertiport. Connectivity and accessibility are the key factors in our design process. With its proximity to highways and ample parking areas for containers and trucks, the location provides convenient access for last mile distribution and passengers, facilitating transfers between different modes of transportation. As we envision the future of the selected location, we recognize the immense potential for the urban development and growth. The planned connections to the underground line present an exciting opportunities to enhance connectivity and seamlessly integrate the Vertiport with the existing urban fabric. With this in mind, our design approach takes into account the anticipated developments, allowing us to align the layout and infrastructure of the Vertiport with the evolving urban landscape. By carefully considering the future urban context, we design a Vertiport that not only meets the current needs, but also adapts and integrates seamlessly with the future developments. This forward-thinking approach ensures that the Vertiport will not only serve as a functional transportation hub, but also contribute to the overall transformation of the surrounding area. One crucial consideration that greatly influences the design and functionality of the Vertiport is the absence of tall buildings or towers in its vicinity. The absence of tall buildings or towers around the Vertiport serves several important purposes. Firstly, it eliminates potential obstacles or obstructions that could hinder the safe takeoff and landing for eVTOLs. By providing an open and unobstructed airspace, we create a conducive environment for seamless operations and minimize the risk of collisions or accidents. Additionally, the absence of tall buildings allows for improved air circulation and wind pattern around the Vertiport. This can have a positive impact on the overall aerodynamics and flight conditions for eVTOLs, enhancing their maneuverability and efficiency. It also reduces the potential for turbulence caused by the tall structures, ensuring a smoother and more comfortable experience for passengers. Furthermore, by selecting a location free from tall buildings or towers, we prioritize the safety and well-being of the surrounding community. With a clear visibility and obstructed lines of sight, both pilots and ground personnel can effectively monitor and manage operations, mitigating any potential risks and ensuring a high level of safety for all stakeholders. Well, to provide a comprehensive overview of the design scope and scale, it's important to note that the designated site for the Vertiport project boasts well-defined borders measuring 328 feet by 459 feet. This area allows us ample space to develop a Vertiport layout that can effectively accommodate all the necessary infrastructure and facilities. With a total project area spanning 8.6 acres, we have the opportunity to create a vertiport that is not only functional, but also aesthetically pleasing. This space enables us to carefully plan and allocate areas for critical components, such as the fetus, final approach and takeoff zones, passenger terminal, cargo hub, and other essential support structures. By utilizing this wide area, the size and layout of Vertiport is thoughtfully planned to facilitate smooth traffic flow, streamline operations, and seamless connectivity between different areas. Moreover, the project area allows for flexibility in the placement and configuration of various facilities within the Vertiport. We carefully designed the layout to maximize the space utilization, enhance safety measures, and provide convenient access for both user and staff. At an architectural level, it's necessary to determine the maximum overall volume by extrapolating the maximum construction area of approximately 2.47 acres for 2.8 million cubic feet. This area will be used as a basic to optimize the size of the vertiport and maximize the return on investment. To ensure eco-sustainability, the vertiport will be constructed using recycled and recyclable materials such as aluminum, steel, glass, wood, and others. By incorporating these environmentally friendly materials, we can minimize the project's ecological footprint. By considering this architectural consideration, we design a vertiport that efficiently utilizes the available space and maximize its functionality. The architectural form of the vertiport must also consider the prevailing wind pattern. In this case, with the main wind blowing from the west to east, the design of vertiport effectively accommodates these flows while providing the necessary shelter for the VTOL's aircraft takeoff area. By incorporating the wind pattern into the design, the building can be sculptured in a way that channels the wind, creating internal microventilation. This natural air exchange and cooling system can significantly reduce the overall air conditioning costs. Additionally, specific wind blends can be strategically positioned the harness to the wind and generate energy for the vertiport. The integration of wind flow consideration contributes to the energy efficiency of the vertiport in alignment with our commitment to creating environmentally responsible infrastructure. The shape of the vertiport must also take into account the correct orientation with respect to the sun. This is to better position the photovoltaic surface to optimize the energy production. As in this case, with photovoltaic panels positioned to the southwest with an inclination of about 30 degrees, for each square meters of surface, it will be possible to obtain over 200 watts. In this case, we'll be able to obtain a total of 100 kilowatts. This integration of solar power contributes to the vertiport's energy independence and resilience by utilizing clean and renewable energy sources, reducing the carbon footprint of the vertiport and surrounding areas. The vertiport is not simple an VTOL takeoff area, but must be a building capable of providing experimental multipurpose area. This because flying with a urban air mobility aircraft must be considered a very unique experience with a great emotional and physical impact on the user. For this, We need to provide user experience areas, training area, lounge, relaxation, exhibition, and events area. Obviously, the technical, commercial, and catering areas must also be considered. As regards the subdivision of the micro areas, in this case, we have the cargo hub area for loading and uploading goods, approximately 2/6 of the total area, detached and self-sufficient compared to the passengers urban air mobility aircraft takeoff areas connected to the Vertiport terminal, which will use the remaining 4/6 of the total area. The general sizing of the surface must be calculated considering 5 square meters per person. The areas must be sized not only on the basic on the passengers flow, which in this case of a vertiport are not so numerous, given that today each aircraft can carry maximum 4 or 6 passengers. The predominant flow will therefore not be given by travel, but by visitors to the vertiport, which will become attractive, a sort of experimental hub. Well, this is the final result. A vertiport with organic shape, captured by the wind, with surface in favor of the sun to obtain clean energy. A large canopy dedicated to the takeoff EVTOLs, protected from the wind, positioned with the Z configuration, no less than 3 FATOs for passengers aircraft and 1 FATO for cargo aircraft, with specific routes for the flow of people, goods, and safety. As we develop vertiports within the smart city landscape, it's essential to understand the key consideration for designing ground infrastructure from a smart city perspective. By integrating the principle of the multimodal connectivity, smart traffic management, sustainable infrastructure, last mile connectivity, and digital integration, we can create vertiports that seamlessly integrate into the fabric of a smart city. These design elements not only enhance to the efficiency and convenience of the air mobility operations, but also contribute to the overall sustainability and livability of the city. The first project, the Baobab, winner the prestigious 2022 Green Good Design Awards. This is the Baobab, was inspired by the shape of the famous African tree. It's a vertiport for protected areas, natural reserves. Here we design an eco-sustainable tower 30 meters high, 98.4 feet, with panoramic welcome area, restaurant, coffee shop, and command and control area. On the top, we placed a photovoltaic landing platform for passengers aircraft. It looks like a roof garden where EVTOLs can recharge in a wireless way. In the second vertiport, called Hamamalis, the shape was inspired by the ancient plant that is able to launch its own seeds to several meters away. With this vision in mind, we created a technological flower that can launch its own EVTOLs. In this case, the structure is low and floating and very organic in shape. The ground is dedicated to the welcome area, commercial area, restaurants, and command and control area. All is solar powered and wind, with the use of recyclable materials in construction. Another project, this initiative concentrates on erected and elevated vertiport at the Foundation Exhibition and Research Center. As a part of its consultative strategy, Evertosky is poised to provide its expertise in deploying ground and airspace architecture. It's contributing to sustainable infrastructure planning in urban air mobility activation. The design of the Leve Montalcini Foundation vertiport prominently features a telescopic elevator and landing platform catered for EVTOL passengers, commutes, and cargo. Vertisky blends biomimicry, solar lighting, and paving materials into the Vertiport's design and construction. We are proud to be actively engaged in various international projects focused on smart and eco-sustainable infrastructure. One notable project is our involvement in the development of Green Island for the Italian National Waste Company. This initiative includes the creation of the charging hubs and smart routes in Italy and Europe with a comprehensive design approach that encompasses interior design and off-grid urban furniture inspired by nature. Our commitment to sustainability and innovation has been recognized with the esteemed 2023 Greenwood Design Awards from the Chicago Athenaeum. Through this project, we aim to drive the transition towards a greener and more connected future, integrating smart technologies and eco-conscious design principles into our infrastructure developments. With this, I conclude. Thank you for your participation. Handing over to our CEO.
Thank you for joining us on this exciting journey with Vertisky. While the webinar may have concluded, our progress and innovation never stops. Vertisky is engaged in numerous UAM, Vertiport, and aerospace projects across the United States and Europe. Big announcements are at the horizon, so stay tuned and see you soon. Ciao.